So first thing is to import the matplotlib dot the plot as anything you want. I will take it as plt. Okay, so first thing is to import this, and let's do some revision of the plotting we have dealt it now. So not here, yeah. So plotting to our canvas, or yes, let's say I want to plot a simple thing. It's a 1, 2, 3. And there I need to plot 4, 5, and 1. Okay, and then show what you have not it's you have plotted. That is your plt.show, and show it. That's all. So this is your graph, right? So with the 3 line of codes, you can generate a basic graph with the Python Matplotlib, right? Simple, isn't it? So let's see how we can add title, labels, and graph again for the basic one. In the same, let's say I have X and Y. Okay, let's say some X and Y, some values. So this is just a revision, guys. Okay, so let's plot X label, let it be anything. It be X axis. And let this be. Alright. So this is your graph, right? This is a portion of the title, the X label, and the Y label, right? So I think it would be clear to you, right? Similarly, let's see something new today. So we'll import the grid one, right? With the grid, remember what are grids like? It's a kind of a line in the rows and the columns. Some lines are there, like we used to write. Do mathematics in class 1 and 2 in the box copy. Remember that were also called as the grid copies, right? So we'll try to do that. So for that, what will I have to do is I have to import the matplotlib. Okay, let's do it first. Right there. Let's say x is equals to some points. Let it be 5, 8, and 10. Similarly, let's take y as some points. Let they be 12, 16, and 6. Let's take x1. Okay, let's take it here. Okay. So x1 be some points, let's say 6, 9, and 11. And x2 be some points. Let them be 6, 15, 7. Alright. So we have some of these points, right? So what I want to do is I just want to plot a graph. Let's say plt.plot and plot the x and y. Let's say with the green colors. So it's green, and now I'll be plotting 2 graphs. So I'll be using the label. Let's say this is line 1, and this is having a line width of 5. Okay, so line width of 5. And again, let's plot something else. Let's say we're plotting x1 and the y1. Alright, and this could be red color. Let's say my label is the line 2, and my line width be 5. That's it. Now I'll be using title and let's say epic info. Okay, and meanwhile let's take y label as y axis, take x label as the x axis, and let's take the grid. Let's say this is true, and grid color will be grid color, let it be yellow. Right, and at last plot the legend, and then this show up there. Someone came once. Right, so just plot these things, and let me see x1 and not y1. It's x2. Okay, let it be y1. Fine, so these are points, these are the colors, these are labels, line width, title, grid, legend. Legend will plot this label particularly. Let's see if some error comes or not. Oh, cool. So this is your epic info with some of the grids and the line width specifying your line 1, line 2. Alright, fine guys. So clear everyone, I think there is no such particular step which is kind of messy, right? So you have x, y, x1, y1, your 4 points. You plot x and y with green colors giving a label of line 1, that is a green color line 1, having a line width of 5. Similarly x1 red line having a line width of 5. You just plotted the title of the graph, the x label, y label, and plotted that grid is true, right? That is, if you give false, it not come. So grid is true, okay, and the color of the grid I wanted as yellow, and I just plotted the legend. Legend is always used when you use label, you always use the legend to plot there, right? And there you come with the legend, and then you show it there. It's look like this, okay. Yeah, so it depends if you use some styles also. If you use styles like ggplot or anything else, that will come like that. Okay. Then we saw the bar graph, I think, right? So bar graph uses the bar to compare the data among different categories, right? So let's see that. Let's say bar graph. So this is, anyone having confusion in the above graph? Yes, let me check. No confusions, I hope no confusion would be there. Any confusion there in this section? No, I think no confusion are there. Why? Fine. Let's move to the bar graph. So what I said as previous class, that bar graph uses some bars to compare data among some different categories, right? So it will well suited when you want to just measure the changes over a period of time. Okay, so let's plot some bar graph there. Let's say it's a plt dot a bar graph simply, and the information I'm using is, let's give some of the data and just plot it there. So 0.25, 1.25, let's take this 2.25, 3.25, 4.25. All right. So this is my x, and let's say this is my y. So my y are, let's say 50, 20, no, 50, 40, 70, 80, and let's say 20. Okay, these are just my x and y. What I 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. Similarly, I'm taking my labels now. So my label I'm taking it as kind of BMW. Alright, and then I'm taking my width. the width of the histogram, bar graph to be the 0.5, right? So these are the things I'm taking on. Now let's give this plotted there. Okay, so this is this kind of a graph. So why I'm using label, because I'm going to plot some 2-bar graphs. So for differentiating it, I'm just using the labels there. So let's plot maybe another bar graph. So that would be 0.75, 1.75, 2.75, 3.75, 4.75. Okay, so these are my the kind of values. Let's say 80, 20, 20, 50, 60. And again, I'll give some labels. Now let's give it as Audi and give this a width. Let this be 0.5 only. Alright, so we have these 2 graphs plotting there, and again, as I'm using the labels, I'll be plotting out the legend. Meanwhile, I'll giving a title to the graph, and the title would be, say, raw information. Alright, so it is a kind of a raw information. Let's say it's a kind of X label, and the label would be the days. The Y label would be information. Alright, so the days versus the information. Let's say rather than of information, let's write it as a distance in kilometers. Okay, so distance in the kilometers, and that's all. Let's just show it. Hope no errors. There is an error. Shape mismatch. Okay, let's see what is the error there.
Line 1, sir.
Shape mismatch. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Line 1 is having error. Alright.
2,25, sir. That is 2.25.
Yeah. This is an error. Thank you. Cool. So this is the bar graph, right? Raw information of the days versus the distance in kilometers. So these are the Audis and the BMWs there. Alright. That's good, right? So I plotted just the comparison between the distance covered by the 2 cars, right, for the BMW and the Audi over a period of 5 days, right? So let's see the histogram now. Okay, summing up the bar graph, you have aware of the bar graphs, right? So let's go to the histogram. So histogram are particularly used. Okay, so these are used to show a distribution, whereas a bar chart, you can say, is used to compare some different identities. Okay, so histogram are useful when you have arrays of a very long list and you need to plot it with the bins and all those. Okay, so here bins are nothing but you can say the size or the intervals, you can say it as. Okay, so let's make a histogram there and we'll see it. Let's say let's take some population. Let it be 22, 55, 62, 45, 21, 22, 34, 42, 42, 102, 95, 110, okay, 120, 70, 65, 55. So I'm taking this much data because the more data you have, the better histogram you will get. 75. How many we have to know? Alright, let's give some more. 54, 44, 43, 42, 48. Okay, that's good. Alright, so we have populations. Let's see the length of the population. 29. Okay. Now let's take our bins. That will be our intervals. So bin can be an interval of the same like range, right? So those should be in equal intervals, like for a class you say, right? So 0, 10, 20, 30, 40, 50, 60, 70, 80, 100. So that can be in the intervals of 10. I have taken there. Let's plot a histogram and say I'm going to plot the population. Okay, I'm going to give the population, and this is particularly the age of the population. So I want to plot the population of the age, or age population, on the basis of my bins. Right? And histogram type I will be using is a bar run. Okay, so I've defined there. And also the writing the r width, which is your width. So it's giving 0.8. That's all. Let's see if we write on the x label. So in the x label, write age of groups. In the y label, write down number of people and give it as a title. Okay, so it's histogram. Population age has been not defined already. So this is your histogram. Alright. Now you can make it bigger, and if you want, you can make it a bigger one. How? That is your fixed size. Give your fixed size, let's say 10 cross 5. So this is your histogram. It depends on you what the size you are giving on. These are the age groups, and we are having the number of people there. So it's 40 to 45 or 46, any particular range. You are having basically getting the data, right? So our biggest age group is between the 40 and the 50. That is clearly visible from the histogram. Alright. So there are kind of scatter plotting also. So in scatter plot, usually we need to plot some data over a dot, right? So we need scatter plot in order to compare some variables. So how much of one variable is affected by the another variable, like to build a relationship. So the scatter plot we'll be seeing in the modeling technique of when we'll be doing unsupervised learning, the machine learning there. So there will be just focusing on the that scatter plots, mainly on those things. Okay, there you'll be getting as this clustering particularly process called as. All right. Okay, let's see the scatter plot. So scatter plot will have some, okay, it will also need some data. So let's give it 1, 1.5, 2, 2. Okay, my eye has been affected, I think. 2, 2.5, 3, 3.5, and 3.6. So 1, 1.5, 2, 2.5, 3, 3.5, and 3.6. That's correct. Let's take for y. 7.5, 8, 8.5, 9, 9.5, 10, 10.5. Similarly, let's take x1. So 8, 8.5, 9, 9.5, 10, 10.5, 11, and for the x2, 3, 3.5, 4, 4.5, 5, 5.2. So these are my x, y, x1 and y2, some random values. Okay. Now you need to plot some scatter plots. So scatter plotting will be based on the x and y, and you will be giving the labels. Let's say I'm writing for the this as the high income. All right. So it says that these are high income, low savings, and this color I want it to be red. Similarly, x1 and y1. Now let this be low income, high salary. Color you'll be getting, let's say blue. That's enough. Let's write the x label. So what should be the x label? Let's give our x label as saving multiplied by 100. And the y as the income multiplied by 100. And let the title be a scatter plot. And since we are using the labels, so legend is compulsory again. And then the last thing, show it. X and y must be of same size. Very good. So the error is in the 8th line. Let's take a point here. And still is there. Alright. Oh. Alright, I find there. So 1 second, guys. Let me have some waters. Okay, so these are the income multiplied by 100 and the savings, and they multiply by 100, and you can see some scatter plottings over there. Okay, so this can be used for it, right? So we'll be using these things in the Seaborn also, but not now. So these are the kind of things you are plotting there, right? Similarly, you have area plottings. So in the area plot are pretty much very similar as to the line plots we do in the line plots, right? So area plots are also known as kind of a stack plots. So these plots can be used to track changes over time for 2 days or related like those things, right? So let's plot these things also. We'll see how it works on. Let's say that they, any confusions there? So let's say the days are 1, 2, 3, 4, 5, 4. So these are the days, and let's take some random data. Let's say sleeping time is 7, 8, 6, 11, 7. Okay. And the eating time, let's take is 2, 3, 4, 3, 2. Let's take the working time. So working could be 7, 8, 7, 2, 2. Alright. Similarly, let's take the playing time. So playing can be 8, 5, 7, 8, 13, and like that. So we have days and we have some of the values there. Now I just want to plot a graph. So I will plot some blank spaces now. And I'll give this color as the magenta. And we'll give the label as sleeping. And the line width to be 8. Let's say 0.5. Okay, so these are the line, just one plot. I'll say we'll have using the blank lines there. Let's give a color of cyan. Let's copy this and we'll change only some of the points. So let's give a color of an R, and let's say this is a category of working. Everything remains same. Let's take this as K black, and let's say it's a kind of playing. So these are the kinds, okay? And let's take some more. Plots, the days, sleeping, the eating, working, the playing. Give them colors accordingly: M, C, C R K. Okay, and also gives the X label. Now let's say this as the X axis. So see guys, I'm having some days 1, 2, 3, 4, 5, and I'm having some sleeping, eating, working, and playing values for the 5 days, right? So I'm plotting some things. Let it be any data there, X and Y could be any kind of data, and I'm plotting these in the color of the M label is this and line with this. Okay. So let's compile the work and we'll see what. So we have time spent on the categories. If we just run this and we'll see a graph. So we can see that we have time, total the time basically based on these categories. We have time based on the sleeping, eating, working, and playing there. Okay, so these are the kind we have used. So we have given the areas to be measured automatically here. There is X and Y. These are the blank areas we want to plot. Okay, there is nothing to just plot on. We just want labeling to be plotted there. We just want sleeping to be plotted, and we haven't gave any parameter because we have these content here, variables as a variables. So we have just defined some two boxes over there. There would be a empty list, so there will be the value of these particular thing what I am writing. So we want to plot the days, sleeping, eating, working, and the colors, and we have provided the colors, and so the colors has given the boxes. Okay, so if these are the kind. Okay, next see the pie chart. We have seen the pie chart, right? So we have these data. Just see a pie chart of these things. Okay, so let's say that the slices I'll be using now. So give these slices, that is 7 to 13 and like that. Okay, so give it as a kind of a slices now. These are my slices. Alright, and also let's say my activities. So the activities here are sleeping, eating. We saw pie chart from the previous day, right? Working, playing. These are the kinds. And let's say the colors to be C, M, R, B. These are the colors. Okay. That's all. So let's plot a pie chart and we'll give it as slices to be plotted out. Alright. So slices are to be plotting 1, 2, 3, 4, and we want my labels to be the activities it is having, and then the colors to be the COLS. Then say that now I'm using the start angle. Now start angle will say what, see it's a kind of a pie plot, and if you just give, so you will having a parameter. By default you have all these things in the pie plot. Okay, by default there are a lot of things in the pie plot to work: explode, labels, color, auto PCT distance, shadow, and start angle. So I'm using the start angle. So start angle will say from which angle I'm going to start from there. So I give it as 90 degree. So I want the 90 degree starting from the 90 degree there. Okay. Similarly, I'm giving, I want shadow. So this is shadow, and let's say shadow's value is true. Okay, and explode you guys know, right? So if you need to highlight any point, we'll be using explode there. So 0.1, 0, 0. Okay, and 1, 2, 3, 4 point. So autopacity would be %1.1f. Uh, Slices done, labels done. So these things are done right. Fine. So this is my pie plot, and then I'll write it a title. No error should be there. Okay, so as you can see guys, there are some shadows over there, right? So you can see there are some of the shadows coming. Okay, and you are getting the percentage there. So it's 90 degrees starting from the 90-degree here. I mean to start from here too. So my first thing is sleeping. So it's starting from the 90 degree, and they're coming at the sleeping, and then the eating, working, and the playing section. Okay. So this data is having someone who's is moreover interested in playing most of the times, and it's natural if he's playing for many times, then he will be sleeping a lot of the time. So these are the pi, and you can see explode is 0.1. The second thing I have exploded out. So you can see that one, this is my one sleeping, and the second one has been exploded 0.1. Okay, so eating has been taken off and has been highlighted there. So these are the things we have used on. Okay, so similarly you plot some graphs, live graphs, and all of the things, right? So you can plot the working Matplotlib or the datas particularly, right? So we have discussed the subplots and everything now till now. So that is here your Matplotlib comes as a compile, or you can say we just sum up the Matplotlib. So in the data science we have some of the more dealings that is not of your use. Let it be there. So this was a concept of a pie plot, of a stack plot. This is not very much useful for you. Okay. This is a scatter plot. This is very much useful for your field, that is AIML. This is useful for you guys. This is useful. Histogram, bar plot are useful. Line plots are very useful, and these things, right? So these are some of the conceptual things based on your Matplotlib. So here Matplotlib just comes on an end. Okay, so we will write the NumPy from tomorrow. We'll start NumPy. For now, see that where is your file data assignments. So this is your first test, that is today at 4:45. Okay, so it will start in the 4:45. Your test will be having some of the questions. So these are the questions. You'll be given the time limit till 6:45 or 7. So you have to submit this by 7, this Python test, and some assignments of no. Yeah. So some assignments, some probably 1, 2, 3, 4 questions are there to find out for the Matplotlib. Okay. It is interesting to find out. Okay. So, and meanwhile guys, I'm giving you just one data, that is of your important questions, right? So those are, well, let me discuss with you there. So two of your library has been completed, like for the SIMP and the Matplotlib. Okay. Now it is your two most libraries. Three of the most libraries you need to learn is the NumPy, the Pandas, the scikit-learn, that is properly based on machine learning, and your Seaborn. So to visualize the models or to visualize the graphs, we will be using the Seaborn. Okay, not for the Matplotlib, we'll be using the Seaborn. So these are the four main libraries we'll be focusing on. Right? We have read how to do mathematical calculations. We'll be seeing in the NumPy mathematical calculations. Now to represent those mathematical calculations, we have read the SIMP to work on, right? And SciPy is also very similar to the NumPy ones. Okay, that's a just a combination of that. So we have read some of the important interview questions on the string, a basic structure, a basic introduction to the important questions which could come as an interview, the questions, right? So if the question is, how would you confirm that two strings have the same identity, right? So for that, what you'll do is you'll be checking with the is operator or the true operator, and then you could come with a solution there. So I will give you study this, right? And how would you check that if each of the strings begin with a capital letter? That's a very easy method. You will be using its title, or you'll be checking with the capitalization. So if the first letter, so it says if each word, so yeah, you will be using its title there. Okay. So similarly, check if the string contains a specific substring or not. That is, this question is like check if the string contains a specific substring. So you might get confused what are the kind of the substring and the strings are there. So it's nothing. It's asking you for check whether a part of a string is there in the whole string or not. Okay, you have this whole string, and you are checking whether this part of this substring is there in this string or not. Okay, sen is nothing but a string, right? So this is right. These are the kind of questions, and you have some around 41 questions based on the only on the string, nothing else. Okay, so these are properly based on the strings, and you can study on, and you have your test also. These are the 5 questions, basic 5 questions. From tomorrow we'll start NumPy, and these are okay. So starting from the NumPy, let's complete one more thing here. Just let me write it one more graph. So in the NumPy we also see that how to plot some live graphs and all those things. Okay, so you know what does a live graph just says out? So live graph is something which will be keep on going and going like that in the Python, right? So how you can make a live graph? It's again very easy. You will have to import the animations and all those things, and then you can just make it a graph moving on there. So if you want to see, just let you see there how you can write down. It's very easy. That is important also with the use of for loops and all those things. So there you will be using some styles. So there are names of the styles. It's 538. There are ggplot and many other styles are there. Let it be figured. Create dot figure. Let it be axis. Let the axis be, let's give the subplotting. Okay, and this will be 1, 1, and 1. Now this is kind of the style use we have defined. Okay, now let's give some animation. So for the right animation, I'll be writing a function there. Let's say it's animate. The parameter is I. So let's take this as a graph data now. Let's say that could probably work or not if I go on repeating it. That would work or not. There is a chance it will work if I make it like okay. Right, it is. So let these my 4 points, and let's say it's 0. Expand and the I. Okay. Style is not defined. All right. You can say it is both style. PL, not PL, it's PLT. Alright, so you can see a graph working there. So that's probably a graph we'll use in the AI to detect some of the systems, like for the these are the graph which will keep on going and going. Alright, so it's only thing to stop it, kind of stop this program. The only method to stop it is kind of that, right? So live graphs will be keeping on, like for the sine graph or the cos graph, it will keep on going there. Okay, so this particular process is used for detecting anything if you're coming inside in front of a camera or not, right? So when you detect, we'll be doing a project in the AIML of a motion detector system. So there will be using this concept to make a plotting of the graph. Okay, so let this to be a blank. I'm not running this. So when you run this, it will keep on going and going. So make sure that you have done it till only the 10, and then you can run it. So it will go only for the less value. That is all. That is of 10. Okay. Started from there and gone till 10. So you can use for a lesser value, you will be getting there, right? Meanwhile, you can use for seeing it as a sine graph or something like that, right? You can use the sine graph or anything for the live representation of your data. So we'll be using those things in the pandas when we'll study those things. We'll be having the live graph simulations or plottings, you can say as. Okay, so those will be a good thing to learn. So this can be also treated as a sensor graph, you can say on. Okay, that can be treated as a sensor graph. All right, so here let's sum